Hello friends, now we are going to learn NP complete and NP hard problems, right, as a part of the module 5. Remember that there are different kinds of problems, right? There is a problem where we can decide that there is a solutions for that given problem. Whether approach will give you or take the more time or lesser time, that does not matter. But yes, by seeing that problem statements, will be having some decision in the mind. Yes, I'm having some solutions to solve the problem, right? So those kind of problem is, remember that, is considered to be decision oriented problem, where you are making the decision yes or no, right? A proper decision, right? Whether A is lesser than B or not. Yeah, that kind of problem is called decision problem, decision oriented problems. There is second problems. What we are going to address is optimizations problem, and we have already learned optimizations problem, and we already find the optimal solutions for the given problems. We have applied dynamic programmings to finding the optimal solutions, right? We have applied greedy method, right? We have applied branch and bond technique, right? So we have seen in different problem scenarios like an abstract problem, a traveling salesperson's problem, Bellman-Ford algorithms, right? How to find the optimal solutions. Now, under this topic, we are going to discuss some basic concepts, then non-deterministic algorithms, P, NP complete and NP hard classes. As I said you that there is some problem and their solutions exist, right? And it take lesser time or some amount of time to solve the problem. Okay, so those time is called polynomial time. If you are able to solve the problems, right, there is a solutions, there is algorithms, there is a process, and you are able to solve the problems, those kind of problems comes under P part, polynomial time problems. NP is non-deterministic polynomial. Now, non-deterministic polynomial is what? Here, maybe it will not take direct lesser amount of time, it will take more amount of time to solve the problem. Maybe will not have direct method to solve the problems, right? But once you are getting some solutions, we are going to validate that also, verify that also, yes, given solutions are proper or not. Okay. NP complete and NP hard problems. Remember, when you are talking about NP complete, it is combination of polynomial time, right? But yes, there is solutions, there is a approach we can solve the problems, right? So basically NP complete is lie between both the sides, NP hard side as well as NP side. Okay, so what will happen here is, if there is no approach, there is algorithms, there is a solutions to solve that problem, approach to solve that problem in polynomial time or non-polynomial time, right? And we are able to verify those solutions, is called NP complete. But there is a second part where we don't know exactly how much time it will take. We can start, but we don't know how much amount of time is required to solve the problem. Exponential time, very long time, right? Then those kind of problems called NP hard problems. NP hard problems, right? So let us see that and discuss how exactly we are going to understand this particular topic in better way with an examples. Look, basic concepts as problem types is optimizations and decision. Optimizations problem find solutions that maximize or minimize some objective functions. Decision problem is answer yes or no to a questions. Many problems have a decisions, and optimizations version, as for example, traveling salesperson's problem, right, is optimizations problem. Knapsack problem is optimizations problem, right? Assignment problem is optimizations problem. Okay, So if you see that time taken to solve traveling salesperson's problem, if you are applying brute force technique, right, it will take factorial time, n factorial time to solve the problem. If you are going with dynamic programming, right, then it will take lesser amount of time compared to brute force technique. But yes, it will take, exponential time in the form of 2 to the power n, right? Similarly, we have assignment problem. If you are applying brute force technique, again it will take n factorial time, right? So our intention is how to decrease this time complexity, how to solve this problem such a way that it reduce from time complexity what is really required in the brute force technique and other method, right? That is what basically here is polynomial. I will show you with the graph what exactly these all terms are, P, NP, NP completes are. Even optimization problem we are talking about, find Hamiltonian cycle of minimum length. We have discussed that Hamiltonian cycle. Okay, we can start the journey from one vertex by visiting all the vertex exactly once and come back to the same vertex is Hamiltonian cycle. But if it is mentioned that find the solutions for Hamiltonian cycle for the minimum length, when you are talking about the minimum length, it means number of edges must be lesser. Number of edges must be lesser, right? Now, another is decision problem examples. You can say that similar concept, Hamiltonian cycle problem. Find Hamiltonian cycle problem of length less than equal to m. So decision problems are more convenient for the formal investigations of their complexity. Now let us see that how we can discuss example called knapsack problems based on non-deterministic polynomial example. So let us see that what is class P and class NP. P is what? The class of decision problem that are solvable in O of P of n. Remember that we have discussed notation O, big O notations, right? In very first module, asymptotic notations. So big O notations, here is P of n is input size and P of n is polynomial time for that input. So where P of n is polynomial of problems input size n. If we see that example, then we have searching problem, element uniqueness, whether all the elements are present in the list are unique or not, means duplicate elements are not there. Graph connectivity, whether each and every vertex are connected with other vertex or not, as we have seen that graph connectivity by using DFS method, right? Graph acyclicity, whether in a graph there is we are going to check whether all the graphs are acyclic or not, right? It means there is no cycle present in the graph, and we have used that concept for topological sorting to check whether first graph is having any cycle or not. Even for the Bellman-Ford algorithms also we have checked whether graph is having any negative cycle or not. If there is a negative cycle, then we will write there is no solution is possible. Okay. NP, non-deterministic polynomial, class of decision problem whose proposed solutions can be verified in polynomial time is equal to solvable by non-deterministic polynomial algorithms. It means there is algorithms, right? It is called it as non-deterministic polynomial because it's taking, right, that not fixed amount of polynomial time. We are not able to determine, right, how much exactly it will take time to solve the problem. But yes, we are going to verify that whether solutions are proper or not. A deterministic polynomial algorithms is an abstract two-stage procedure that generate a random strings, right, purported to solve the problem. Check whether this solution is correct in polynomial time or not. right? So basically we are going to check whether this problem is solved in the polynomial time, right? That is called NP complete part. Okay, that is called basically here NP complete part, where you are saying that problem is solvable and it is been verified in non-deterministic polynomial time is NP complete. Let us see that non-deterministic knapsack algorithms. We have already heard that there is a knapsack problems, right? And we found already optimal solutions by using dynamic programming, by using greedy method, right? By using branch and bond technique. We have already found. But how this NP knapsack problem is different? Yes. In previous cases, we don't have any restriction based on the profit. Whatever the optimal values you are getting, that is the final profit based on the given knapsack capacity. Now here, some person will ask you to find the solutions for the knapsack where overall profit must be greater than so and so values. Okay. So say as for example, where capacity of knapsack is W, right? And Wi and Pi is weight and profit of all ith items, or you can say element. What we have, W of I and P of I is a weight and profit of all I element. It means element 1 will have their weight and profit, element 2 will have their weight and profit, so on. Now, based on non-deterministic part, either we have choice, what we are saying that x of I is element to be selected in the choice, either it will be 0 or 1. When you are saying 0, element is selected. When you are saying 1, element is, 0 element is not selected. When you are saying 1, element is selected. So that is called choice. When you are talking about the weight, W, right, should be multiple of Wi, weight of that Wi and ith element x of I. If element is selected, x of I must be multiplied by W of I. If element is not selected, no need of multiplying it. I repeat, if element is selected, we are going to multiply Wi with x of I. If element is not selected, no need of multiplying because this value is 0. Right? We are not selecting that element. Likewise, you are going to find optimal solutions. Similarly, for weight, we said that weight you are going to find out Wi into xi. Okay. So basically W of I, you can say that Wi xi. Profit, how are you going to find out? Profit you are going to find out P of I multiplied by x of I. So basically these combinations will give you the maximum profit, and weight must be lesser than the overall capacity of the knapsack. Okay. So take it this NDK algorithms and how you are going to address this. NDK, a non-deterministic knapsack algorithms. Say here we have profit of all the element, weight of all the elements, small w, weight of all the elements, right? Say here we have capacity of knapsack. Yes, x is a individual element of knapsack. R, you can say that R is desirable profit, means profit must be greater than these values, R, right? Yes. So based on this, we are going to check whether a given algorithms is giving you proper answer, and capital P is overall profit what you are going to calculate. All right. So let us see that. Now initially capital P we are making 0, right? Capital W is is capacity. Now capacity we are taking capital M. Okay. So P is a profit of individual element, W is a weight of individual element, X is a item, R is a desired profit, right? And P is just we have taken one variable. Similarly, we are going to take W as another variable, right? And M is a capital M is a total capacity, right? So initialization is 0. Right. Let us see that how many elements we have. I element. For I is equal to 1, I less than equal to n, and I plus plus. This variable you can define based on your choice anywhere. Here first we are going to make it x of I is equal to choice. Maybe choice will be 0 or 1. Element is selected or not selected. Both the choice. If it is selected, then we are going to compute W is equal to W plus capital W plus a small w of I into x of I. This is the weight part. Total weight we have calculated for that ith element along with weight selections. Alright, so it will give you the total weight. Similarly, we are going to find the profit of selected element. So P initialized with the 0, P plus a small Pi profit of I into x of I. Say as for example, you are saying that some elements are 10 rupees per kg and you are going to purchase 5 kg. So you are going to multiply 10 into 5 is 50. So it is as simple as it is. Now you are going to check after performing this task again and again, we are going to check that W, right, must be lesser. W must be lesser. If W, calculated W is greater than capacity M, it is capacity M. So we need to see that M, or see W is calculated weight. What is M? M is the capacity of the knapsack, means capacity of the bag. So that should be not be more than the capacity of the bag. If it is a case of failure. This should be not more than M. Or R is a desired profit. But if you are saying that P is lesser than, right, R, P is lesser than R, either this or this, P is lesser than desired profit, both the case, we can say that, right, it is a case of failure. Then you can say that it is failure case. Else, we can consider it is a success. Remember that what I am trying to say is here, there is a two case. We are talking about the weight and profit. As you are knowing that weight, selected weight should not increase by capacity of the knapsack. So that is the first case. Second case, desired profit is R. So our profit, calculated profit must be greater than R. If you are getting lesser than R, it is case of failure. If not, it means both the conditions are failed. It will come out, it will come in else part, and you can say that it is a success. So this is called non-deterministic knapsack. It will take iteration by iteration to perform the task. Now what is the benefit? If we will go and check with that dynamic programming knapsack or brute force knapsack, right? These all are taking time comes in the form of 2 to the power n or nearby 2 to the power n complexity. So this is the time complexity of knapsack problem. So after certain time, we will get the results in 2 to the power n computational time. Now, if we see these problem scenarios, maybe not get the maximum profit, but here we are just running one for loop, right, from 1 to n. So we are able to reduce the computational time from 2 to the power n to p of n polynomial time, right. So this is basically part of non-deterministic knapsack algorithms. There are similar kind of different algorithms like decision problems, right, searching, sorting. We can explore any other algorithms as well. Let us see that when you are talking about the p problems are solvable in polynomial time, are solvable in O of nk, where k is some constant, means we are talking about O of n, right. So if I multiply constant, it will be basically n or 2n or 3n kind of things, but we have polynomial time is here is n. Most of the algorithms we have covered in p. Non-deterministic polynomial NP problems, this class of problems has solutions that are verifiable, means we can do verifications in polynomial time. Thus any problem in P is also NP. I repeated that if any problem in P is also NP, since we would be able to solve it in polynomial time and we can also verify in polynomial time. NP complete problems is a NP complete NP problems, non-deterministic polynomial time problems is at least as difficult as NP problems, as reducible to it, means you can reduce the time complexity. More formally, a decision problem C is NP complete if C is in MP. It means if NP complete problems, if it is NP, then there is a chance you can say that it is a NP complete as well, right. So problem C is in NP complete if C is in NP. So first condition is that problem to be the part of NP, non-deterministic polynomial. Then you are looking for that NP complete, whether that problem is really difficult, it will take lesser amount of time, more amount of time. That is the scenarios we need to discuss. Let us see that example. Say one problem we are having it. That problem we are solving with the approach A, right? And we got some time complexity, say it is a n cube time complexity. For the different given problems, we are thinking and knowing that this is the process we are going to use the similar kind of solution, similar approach as we solve it in problem A. Then definitely these new problems will take not lesser time complexity than problem A, because problem A we already solved, and since you are solving with the same method, same approach, then it will take either same time or more time compared to the existing method or method you have what you are going to apply. Let us see that we have seen many scenarios of time complexity, right? We'll be having linear complexity, constant, n square, n cube, so on. So if you see that here, we have log n complexity, square root of n complexity. We'll be having, say, if we'll take direct straight line, it is n complexity, right? n log n square. If you take little from here, it will become n cube. Yes. So these all are, when you are talking about the polynomial time, so these all are the polynomial time. Okay. We have some fixed variable. With the fixed variable time approach, we are able to solve in that given amount of time. Now, if you are going towards y, right, with more complexity, say this region is called here NP complete, right. So this basically region is between polynomial time and NP hard time. Now, what is exponential time or hard problems? Computationally hard problems. That is called computationally hard problems, where we have exponential complexity, right? N to the power n to the power n to the power n. It is like exponential, high exponential. Hence, it is called computationally hard problem. Or some problems we are trying to solve the problems, but we are not able to get any answers, right? So that approach will go towards exponential time. Here is 2 power n. 2 power n, as I said you, the time complexity of knapsack problems, right? But still we are having the answer. 2 power 2 power 2 power 2. It is written constant part, but say it is kind of n to the power n, n to the power n to the power n. So it is computationally hard problems, right? And if you are able to see that relationship among P, NP, NP complete and NP hard problems, right, then this particular region, first you focus on this particular region, you will see that a small part, a small circle is called P, means polynomial time. So this kind of problems will have some complexity like n, n square, n cube kind of things. If you are talking about NP, it means that problems can be solved by different approach and we can verify that, right? Or if you are not able to solve, we'll be having the answer, there is no solutions possible for the given problem. Means we are able to make the decision that this particular problems is having no solutions, right? So we make the decision. So that is called NP problems, right? As I said you that for topological sorting, if there is a cyclic path, right, we'll write there is no solutions for this topological sorting. So that is the solution. We are able to make the decision that there is no solutions for the given problem. Say, as for example, Bellman-Ford algorithms having negative weight cycle, right? If some of the age in that particular cycle is having negative, then we'll be concluding that we are not able to apply Bellman-Ford algorithms because it has negative weight cycle. Some of the weight on this particular cycle is negative values. So there is no solutions. So we are able to make the judgment, right? We are not getting any solution for the given problems. Hence it is a part of NP. So in NP you are able to make the decision yes or no. If yes, we'll be getting some solutions. No means you are not getting the solutions and you are able to prove it, right? Here is having NP hard problems, right? So NP hard problems and NP problems, you can see that some intersections part, right? So this intersections part is NP complete. So some of the NP hard problems, we are able to apply some approach, approximation method or some approach process, and we are able to solve the problem in little more amount of time, right? Complexity of the problems will be higher, right? But we are able to make some decision, some answer we are going to get for those kind of problems comes under NP complete. No direct approach, but there is an indirect approach and we can solve the problems. And we are able to make the decision that yes, there is some solutions for this particular problem. Summary based on the given problem, firstly we have to decide whether problem is optimizations problems or decision problems. Thereafter, based on the problem solutions, we can decide whether problem solved in polynomial time or non-deterministic polynomial time. If it is, then we are going to apply the concept, and based on that, whether it is polynomial time, okay, we'll say that it is a part of P problems, other will go towards NP problems. Again, in NP problems, we can make our decisions, right? It means it is a part of NP complete, otherwise it will go towards NP hard problems. Thank you very much.